I'm going to show you how to configure, build and simulate the project in Visual Studio. Here I've opened the MicroTasker project. I then go into the header file config.h and I select the target we want to test. We want to move to the new K22 chip, so I select this as our board type and I go into application.c and here I enable some special test code. This is your keyboard handling, and then I first build the project. Once it's built, we can execute it, but what I'm going to do is I'm going to look at the code which we're interested in. This is your code where you initialize the button, so we're going to put a breakpoint here where it's going to be called. I'm going to start the simulation and we'll hit this breakpoint. Now I'm going to step into this routine so we can have a quick look. Now here we can see that we have a different type of port initialization. These are the bits of the button inputs on the ports and the port pins, and these are the outputs. The way that we configure is using a macro which tells which allows configuring multiple ports on a single, or rather multiple bits on a single port, and also defining their initial drive state. So this line will configure these with these characteristics and drive both of them to 0. The second one will configure these with these characteristics and drive 2 of them to 1, and so on. The code below is doing the interrupt configuration. This is the only one of interest here. I'm configuring on port C 4 interrupt inputs which will all cause the same interrupt handler to be executed, and I've set this up though that any changes, either positive or negative edges, will cause this to happen. This will avoid me any polling, so I'm going to put a breakpoint also on this line so that we can see the interrupt taking place, and I'll let it run. Here we see the simulation in operation. I can here verify that the enumeration works of the USB. That's passed the internal test, so the test enumeration was good. Here are 4 inputs which we've programmed as interrupt inputs, and these are 2 outputs which you're controlling, so we can also see their state. If I change any of these inputs, for example, let's click on this one, it will cause the interrupt to be executed. Now this interrupt is sending an internal event to the application task, so if we go and find the handling of that, I can also put a breakpoint there. We'll then let it run. So any input change causes this routine to be executed. So we're going to check. This is basically your original code. Your original code will be working with a couple of flags. It would have normally be doing polling all of the time, but we don't need this anymore. It will be checking the state of inputs, and depending on what state it will be clearing or setting certain outputs. So I'm going to let this run again, and we'll just use the simulation and we'll see whether we can test the behavior of it. So what we can see here is that depending on the inputs, we can control some of the outputs. You can see the outputs also being manipulated depending on the state of the inputs. So the main difference is initialization of the interrupts, the inputs and the outputs is extremely simple in this environment, and we can also test that all of the interrupt is operating correctly, and of course that the application which we've got written is handling it the way that we're expecting it to work.